Good morning guys and welcome back to another episode here at Barham Engines. Right, so we've got the Conrods here for the V8. Now this is the V8 that's over there, the MGB V8. Now first things first, I've got Paul to torque all these big end nuts up so they're as they would be in the engine. Next thing, we're going to measure the big end housings and to make sure that they measure within tolerance. So I'll show you how to do that. Now what we do is we've got a book here. This is a bearing catalogue, an AE book, bearing catalogue, and it's got all the sizes for the dimensions for the bearings, the rod housings, the crank, etc. So first things first, we look under MG and then we go and find MGB GT V8. So this is the one we want. Then over here we have the part numbers of the parts we want. So AEM will be the main bearings. AEB will be the big end bearings, so that will be the rod housing. So we've just got another different part number here for rod bearings, and then we've got AEC, which will be the camshaft bearings, I would have thought. But anyway, the one we want is AEB, so that's the big end. So if we go over here, we've got dimensions. So if we go up to the top, we've got little drawings here of what we're looking for. So you've got one here of a Conrod, and that is the dimension of the housing in the big end of the Conrod. So if we go back down here, follow this down to the big end, this is the dimensions we want. So at the top there you've got metric, but we all know that I like to work in imperial, so you've got the imperial down the bottom. So what we're looking for here is the tolerance from bottom to top limit. So we've got 2.1247 to 2.1252. So that's near as damn it 2.125 plus or minus 0.2. So what I normally do, and this is just user preference really, John always does it on bottom limit, but I set the bore gauge to top limit. So I'm going to set that bore gauge to 2.1252. So we get our micrometer here, we've got our 2 to 3 mic, and what I do is set it to, you've got 2.125 and we want to go 2.1252. So that is about there. So that is where we want to go. So here's one I made earlier. I've already set the bore gauge up. So I've set the bore gauge up to 2.1252 and that will be with the big hand on the zero. So we know if the hand goes to the zero, these rods are in top limit. So next thing we do is we want to measure them top to bottom. If you have a look at that, you see that rod there is right on top limit. Now, very, very slightly over is not a bad thing, believe it or not, depending on the journal size of the crank. So if John's grinding the crank, what we do is we measure the rods. If they're on top limit, then he's going to grind that crank to top limit when he grinds the journals. So we do it in that dimension. You can see that Conrod there is in that direction. We're right on top limit on the up and down, and then in here we're in limits. We're within limits, but we're getting towards bottom limit there. So what we're going to do is that Conrod there, we don't have to resize it. So if we were too big on this dimension, then we would take it off the rod or the cap or both on this face, and what that would do would close that up and then we can resize it, but we don't really need to do that. We're within limits, but we're more on bottom limit here, so it's getting on towards 1/2 thou oval. So what we're going to do is just run the hone down and see if it opens it up here, and if it does, that's fine, but if it opens it up here, we're just going to resize it. So we're just going to check all these rods, and if they're all the same as that, then we shall run our hone down there, see if it trues them all up. And I like to run them all, as I've said before, I like to run them all towards the top limit side. Right guys, so a little update here. underneath here is the Cosworth engine that we're in the process of building. Still waiting for some bits, but fortunately, all the bits have arrived today. So what we were waiting for, I can't remember whether I said actually in a previous video, but what we've got is all the bits here. The customer sent his own pistons, which are 0.5 oversize, standard piston type, but with the cutouts in already done, the ones like I do in the standard pistons anyway. The only trouble we had was the Conrods that he supplied are obviously H-section rods. What brand they are, we don't know. But these are a long rod type, but they're not as long as the long rods we use. They're slightly shorter than that, but they're not as short as a normal standard height rod. Now the pistons we had in it are those pistons down there, which are a long rod piston, but those pistons are meant for the rods in the length that we can get. So basically when we strip this block down with those pistons in and these slightly shorter rods, those pistons are about 3 mil below the surface of the block, and we wondered why, but that's it. So I spoke to a couple of suppliers and we're not sure what pistons go with these rods because nothing matches up to them. So we're not going to use those. I've had a chat with a customer. I said because he supplied these pistons, we can either go for an aftermarket set of standard rods, a standard set of Cosworth rods, but because he's going big power, he does want to particularly run the long rod setup. So I've managed, because obviously of supply of bits lately in all areas, it's very difficult to get some parts in some sizes. So we've rebored this to 0.5 already to obviously go with these pistons, which we're no longer going to be using. The customer's going to have them back, and he said that once he's done this motor, there may be another engine coming our way soon, so he'll probably use them for that and sort some rods out in the future. But that's by the by. So we've already bored it to 0.5. Now, we've managed to get a set of PEC long rods, which are the correct length to go with the short pistons that you can get. Unfortunately, two things. The piston to go with these rods from PEC are a Wasner piston. One, they haven't got them in 0.5. They've only got them in the round figure, so 91, because they go up in sort of 0.25s on these Wasner pistons. So, and they haven't got the 0.5s anyway. So one, if we did use them and they had them, we'd have to sort of bore that out a bit and take another 1/8 thou out, bit of a pain in the bum. So what I've done is I've gone to Mar Motorsport, our friends there, and we're going to be using these pistons. Now these are a long rod type piston. They're a forged item, obviously. And if I just open one up a moment, the differences with these, very nice product actually, but the differences with these is, I don't know whether these are a sort of WRC type, but they're a flat top piston. So they've got the cutouts in already. These are at 0.5 size wise. We've put these down the bore with one of our PEC rods, and we're getting about 10 thou protrusion on, with the top above the top of the block, which is absolutely ideal. You all know that I like to run about 12 to 15 normally, but 10 thou absolutely fine. But the only problem is I'm going to have to put the bowl in here to match the compression ratio we want to run, which is basically the bowl that's in the standard piston. There is more than enough crown thickness. There's 12 millimeters of crown thickness, the same as in an original Marla. So no issues there. So what I'm going to do is I'm going to set these pistons up in our 4-jaw chuck on the lathe, and we're going to turn that out and basically CC that compared to an original and make sure we get our compression ratio right. Bit of a rigmarole, and the reason I'm going to have to do it in a 4-jaw chuck is because you see the base of this piston is quite narrow here, not so much width of a skirt, so we're not going to be able to hold that in a 3-jaw. I know many of you guys are probably going to say down in the comments, oh, I wouldn't hold them in a jaw, on the lathe. I would probably set them up on the mill and blah de blah. But it's a lot easier on the lathe as long as you don't hold them too tight. We're certainly not going to damage them. Done hundreds of them and not had any problems. So don't worry about that, guys. It will all be fine. So that's what we're going to do. I'm going to take you over to the lathe in a minute and show you how to how to set them up. Right everyone, little update on the Audi A5 with the TFSI engine in that's smoking on the dyno. Just to recap slightly, going back to the last video on this, and the lad has had it sort of 11 months and he sent it to be tuned yet again on the dyno, and the tuner said that it's smoking on the dyno and he doesn't want to take it any further, and that he recommends he brings the car back to the engine builder. So after the big dispute with the customer and trying to get him to realise that the car is not under warranty for any smoking issues, because we didn't bore it, we just fitted pistons and rods into it under his say-so. There was the disclaimer on the invoice. A lot of you guys commented on the last video, thank you very much for that, saying tell him to jog on. Really, it's down to him. It's a very difficult one, because although that's what a lot of people do, we find it very difficult to sort of tell people to just jog on, although we are starting to learn from that, especially having done these videos and that. We tend to listen to you guys, and that's the way it's going these days, and that's what you've got to do to sort of cover your ass. Otherwise, you're just running everyone's vehicle for them. Anyway, update. He got back to me this afternoon after saying that he'd spoke to about 5 different specialists or garages, and they wouldn't touch it because they recommended bringing the engine back to us. So I had a little bit of not a row with him, but a little bit of a dispute over message, and I sort of got a bit tougher and said, listen, read your invoice. It's not under warranty. It's not an issue that we've done. We did not recondition the engine. We just fitted performance parts. The car is tuned way beyond its intentions. Therefore, it's no issue of ours. He did get back to us this afternoon via message saying that he's got 2 people to look at the car. The first person was a Volkswagen specialist. He looked at it and he basically agreed with what I said. He's checked the PCV, he's checked everything else, the compressions and whatever. He said everything's absolutely perfect, and he said that the smoke is actually just a bit of steam really, or white smoke, because there's no catalytic converter. There's absolutely no issue with the engine whatsoever. He did take it just to verify to another friend of his who is a mechanic. He's had a look and he's verified what the first mechanic said. He said there's absolutely nothing to worry about. There's no oil burning whatsoever. So he actually messaged me saying sort of he's sorry and thank you very much for our help. So for all the haters out there, guys, in the comments that say that we get nothing but warranty claims, it's not. If you actually watch the videos, it's not that we get warranty claims and engines come bouncing back every time we do them. Very rarely do we get a sort of dispute. 9 times out of 10, it turns out it's not our fault. If it is our fault, we'll sort it, we'll rectify it. Things happen, we're only human. But 9 times out of 10, it's not our fault. It's very rare. You've got to bear in mind how many videos we do on this and how many engines we actually produce. So, yeah, this one, guys, we're in the clear. He's on his way. I said to him, just enjoy the car, don't push it too hard. And yeah, we've sorted that one, guys. But look out for Monday's video on the next issue. So guys, as you can see, I've started one of these pistons already. We've got our 4-jaw chuck up. So obviously there's the standard 3-jaw chuck. The advantage with the 3-jaw chuck is whichever side you do up, all 3 jaws will come in the same. So whatever you're clamping, providing you can clamp it sort of, it's cylindrical enough to clamp evenly, that thing is going to be pretty much central every time. But unfortunately with the 4-jaw chuck, each jaw is individually wound by its own screw here. So what you have to do is set the piston up in such a manner, fortunately because it's 4-jaw and there's not so much space, we can just about grip on each side of the piston here on the skirt, which is ideal. So what we do to get it central, what I normally do is put this center up, put it up and sort of roughly get the piston as central as I can, roughly, and do everything up loosely. Then what we do is we set the DTI gauge on the outside of the piston, ensuring that the skirt is sitting back and running true, as in the face wise. We put the DTI on the edge of the piston, and then basically we just adjust these jaws to get the piston central. So if we are, say if we're okay this way, like running through here, but we're 10 thou proud here, what we will do is go to the other side, slacken it off 5 thou, and then do this one at 5 thou, and in effect that will move that 5 thou that way and run true. It's a bit of a trial and error, takes a bit of jiggery pokery, and at the end of it they've all got to be tight enough to hold the product, but this is absolutely fine. If I spin this one up now, you will see that that's running absolutely true. So, happy with that. Next step, what we do is we set, or this is what I do, we set that tool up. You see the tool face there? I set that up to the same angle that's in that piston. So then all I have to do is when I'm doing my finishing cut, I just have to come back to the position that I want, and it naturally cuts that angle in the top of the piston with the front of this cutter. We've got 12 millimeters to play with in the crown. The depth of this compared to the top of the piston there is 6 millimeters. So we're going to go 6 millimeters down, coming out to not quite as far out as we want to go, come, you know, to here. And then once we've gone down to our 6 millimeters, we're going to come out and just finish this area here. And then we're going to take the piston out. We're going to CC it compared to the old one and see what we've got. But we should be pretty much there by then. So yeah, let's get this one finished, guys, and we'll get the next one in. This is going to be a fairly lengthy process, but we'll show you the product afterwards. Well, thanks ever so much for watching, guys. Until another episode, have a great weekend, and we will see you on Monday. Cheers, guys.